Hello everybody, welcome again to Advent of Code. This is my 200th video, which is pretty cool, and we will be solving day 12 of Advent of Code 2023 today, so I'm quite excited. This time we will be dealing with hot springs. So, I've already pre-read the description, so I have some plan on how to tackle this. So to summarize what the problem is going to be is that we are getting a list of hot springs that are arranged into rows, and we are getting the information whether the given hot spring is either operational, which is a dot, or damaged, which is a hashtag. And now this kind of spreadsheet is not complete, so we know that for some springs it's the situation is actually unknown, so that's a question mark. So we get a list like this where we get these symbols which tell us which of the springs are damaged or working, and then we know that we also get a list of numeric values which tells us the size of each continuous group of damaged springs. So it means here this list means there is one damaged one, then a dot, then one damaged dot, and three damaged ones. And here the same thing, it's one, some undamaged ones, one damaged, and some undamaged ones, and three damaged ones, and so on. So basically this list describes the situation on the left side. And if in case there is no question mark, it's super easy because there is just one way the whole thing can look. But the problem is when they introduce those question marks, because in that case, some of the hot springs can be either damaged or working, and we need to figure out how many ways, how many different arrangements can be described, how many different arrangements can we assign the values to those question marks to satisfy the list on the right side. So in this case, 113 can be only damaged here and here because we need a dot between them, because they're the continuous group, there cannot be two next to each other. But in this case, there is more options because we can put one damaged one here, another damaged here, or one damage here, another damage here, or so on. So there is more options there. So we need to figure out how many different arrangements of operational and broken springs fit the given criteria in each of the rows. So there is just describing the whole thing, how this can be arranged and how different possibilities can show up. But essentially what we want now is to find a way to efficiently calculate those possible arrangements and to sum up those counts to get the total number of different arrangements across multiple different inputs. So one possible way to do this would be to do it with a recursive function that will try all the different possibilities, which would be possible for smaller inputs like this, but it would be problematic for larger ones. So I think it's worth trying to do this more efficiently. And usually when there is a recursive solution to something, there is also a dynamic programming way to solve the same problem. And dynamic programming is a way where you are building up the solution from smaller ones. By taking known values of smaller solutions, you build up larger ones. So in this case, my idea is to have a two-dimensional array where I will be trying to find a solution for a subset of the length of the input and subset of the length of the description of arrangements. So that is essentially by having the solution to how many ways I can arrange into these first 4 characters, the first two two strings, then I will be able to figure out how many arrangements for the full string by combining those two into one. So it's gonna be kind of combining different arrangements, and hopefully that should work in a general case. So I will start by taking the sample input, and I will start trying to figure out how to solve this. So I will take the input and read all lines, and now for each of the lines I will call a method, or maybe I will parse it and then call the method. So I will create a method that will do get arrangement count, and so the input will be a string of how do they call this? So we throw a condition records, so we bring it and so move for a kind of list. Okay, so maybe I will call it pattern and an array of groups. So this will be the way I will parse it. And now I will have some running total, which will be initial 0. In the end I will output that running total, and I will add running total plus equals get arrangements counts for that line. So I will parse the line by breaking it down by the space. So parts equal line split space. So there's only one space, so no necessary adjustments needed. And the pattern will be parts 0. Groups will be exactly this. So parts 1 split by comma, and then parsing those values to get the groups. So now pattern groups. So now to calculate this thing, I will need to have a 2-dimensional array that will, oh, there's a lot of generated code, arrangements, which will be a 2-dimensional array of length of the pattern and number of groups that we are matching. So it's going to be pattern length and groups length. And now I will be continuously building up this space of values to figure out the real solution, the ultimate solution. So for for subpattern length less than pattern length, I will do a for int group count 0 group count plus plus. And now I will be trying to figure out how many different ways I can arrange the given number of groups into a sub-pattern of a given length. So let me think if should I go like this, or yeah, this should be fine, hopefully. So it's gonna be kind of exploratory how to figure out that proper logic. But so my essentially in one at that given index of, or maybe this would be pattern index and group index. Let's maybe do it like this. So pattern index. So I will be, so I'm for this given index, I will solution will be based on the character that's there. So I will get the character there will be if the character on that index is, if the character on this index is a dot, which is a functional hot spring, it means the number of arrangements is exactly equal to the number of arrangements for the pattern of length -1. So arrangements of pattern index group index is exactly equal to arrangements pattern index -1 group index. Because to accommodate for, but actually, yeah, maybe let's do it like this. So let's group, yeah, maybe let's do it like this actually. Pattern length makes more sense. So pattern length, I will do pattern length minus equal group length. Actually, that was easy. That will be easier to work with. So group length minus equal group length. So I will do +1 here. So for all zeros, I will initialize it to 1 because there is, so for length 0, so for pattern length of 0 and group length of 0, so I will do pattern length minus equal pattern length. So I want to initialize this two zeros, to ones, because there is only one arrangement for pattern length for 0 groups. So if we are trying to arrange 0 groups on any length, it's always going to be one possible way to do it, because there is just one way to match it. So if there is nothing to arrange, actually there is, it's not in the general way. I see. Right. So maybe this is not really the case. So maybe let's do it like this. So if the pattern, the character on the pattern at pattern length, we started at 1. So maybe I'm changing this twice the same thing. So let's try again. It doesn't make sense. I just wanted to have initialized values for the zeros, but maybe that's not really pattern index less than pattern length pattern index. So okay, so I will have group length, group count. That's gonna be like this, but the pattern index itself. So for pattern, for the character that's on the pattern index, I will check if the character is equal to dot, and if it's a dot, then the number of arrangements for this given character is the same as for the previous one. So it's equal to, so arrangements for pattern index group count is equal to arrangements for pattern index -1 group count, unless we are at 0 index, because in that case there is just one arrangement. So if pattern index equals 0, then it's gonna be arrangements pattern index group count equal 1, because there is just one arrangement to arrange. Oh, wait, right? So if we're arranging group count equals 0, then it's going to be 1. Else, if pattern index equals 1, equals 0, and group count greater than 0, it's going to be arrangements pattern index group count equals 0. There is no way to arrange arrange any non-zero groups into a 0 size pattern, and otherwise we do this because we just reuse the previous value from pattern index -1. So that should be correct. So now if the character is a hashtag, we have two options. Option 1 is so you have one option actually. The last group must end with this character. So if it fits there, then we take the number of arrangements for the start for the end of the group, for the length of the group -1, so that we accommodate for that one dot, so that it's not continuous, and if it plus the possible number of arrangements, and if there is no way to fit it into this space, then it's 0 possibilities. So if group size, so we take the size of that group. So okay, so if a group count equals 0, so if we are trying to arrange 0 groups, then the number of arrangements at this place must be 0. Because if we have a hashtag, there is no way to arrange any group. If we have 0 groups, we cannot arrange a hashtag on the, like, we cannot arrange 0 groups on a hashtag. So this is the edge case. And now the last group must endorse this character. So it means that if for so we need to check if pattern let's see, maybe like do for and index. So I will do pattern index. This is the current one, and index greater than pattern index minus group size. Come on, group size plus 1. So we and index minus exactly. So now inside of this, I will check if group true. So if a pattern at end index equals dot, so if there is any dot for the group size that we are trying to place, we have to set can place group false and break. So we now know if we can place it, or if we can place the group, then the number of arrangements for group count for pattern index group count is equal to a number of arrangements of pattern index minus group size, which is minus group size minus 1, because we need to accommodate for that one additional dot before it. So yeah, maybe let's do this like so. Let's do this. Let me close this. So actually, yeah, I'm still thinking I could have done the pattern length here. That's yeah. I could have done that, I think. Yeah, it was a better way, because I could avoid all these ugly things. So maybe let's do it again. Rename this to pattern length. I didn't think this through enough, so it's pattern length 1. So now arrangements of pattern length, that's fine. Arrangements, yeah. So okay. So I will store pattern index as pattern length -1. So at the appropriate places, I will use pattern index, of course. So in here, it should be pattern index minus group size +1. And now it should simplify things. So if I need to initialize the right values. So this for pattern length, so arrangements 0, 0 equals 1. There is no one way to arrange group count of 0 to pattern length of 0. Now for group counts, if there is So for term length zero. I think I like this one is there. So I can skip this. So for, so this is gonna be set already. So there's only one arrangement to do 0 length of 0 groups. And then for if pattern length is 0 and group count is greater than 0, so if we start it with, yeah, it should be fine. So if I do it like this, so if I start with 1, 0, it's gonna be 0, 0, and yeah, so this should be now correct. Now, for group count of 0, there is 0 groups, we can, there is no way to arrange. Yeah, so I can skip this as well. Just hoping I'm not making a mistake here. So if there is, the last group must end on this character, so we get, if we can place the group, then the number of arrangements for this group is equal to arrangements of pattern length group count equals arrangements pattern length minus group size minus 1. So it means one more additional character for the 0 character of for the dot before the group, and group count minus 1. So we excluding this current group count. So that's for character of hashtag. And yeah, I think that should be it, except it should be plus equals here and plus equals here, because we for the question marks, it's both of these options. So character equals question mark, and if character equals question mark, we do this calculation as well. So I think this could be correct, except I'm not sure if we are initializing everything to the right value, but we'll see that very soon. So so the result should be arrangements, pattern lengths, group length. Okay. Okay, we'll see. We'll see. You can verify this on the first example. So pattern is this, and groups are 1, 1, 3. So let's see what happens. So for, okay, I'm outside of bounds of array. So for pattern length of 1 and group count of 1. So yeah, so we are here. It should be pattern 1 minus group size minus 1. All right, because if it's at the beginning, there shouldn't be any dot at the beginning. So if pattern length equals group size, then it's gonna be arrangements pattern length group count plus equals 1. There's just one possible arrangement if group is exactly the size of the pattern so far. So That's an edge case that we need to take into account, because we don't expect a dot before the first one. And what here? Here we have -1. Right, and yeah, of course. If group size, so pattern length is smaller than a group size, we cannot fit it there. So for the group size, then we cannot fit it in that space. So arrangements pattern length group count is 0, and we continue. Yes, that should be fine. All right. So 6 arrangements, that's quite too much, because it should be just 1. Let's see where we're getting things wrong. So initially we have, so we're on the character of, oh, let's try it again. I'll just walk through things line by line. So maybe here. So initially we have one hashtag, so the group should be placeable. So we set it to exactly 1. So the arrangements for 0, 0 is 1, for 1 group and 1 length is 1 as well. So that's correct. Then we have another hashtag. No, we don't. We don't have another hashtag there. Why is there another hashtag? That is odd. So initially I'm on 0. Pattern length is 1. Okay. I'm trying to place the second group on the same pattern length. Okay. Right, so pattern length is 0. We're trying to set there the group size of 1 at that arrangement size, but oh, right, because it must be also the first group if it's at the beginning. So group count equals 1. Yeah, okay. So if group count equals 1, then it's gonna be +1. But otherwise, it's going to be arrangements. So we cannot update that number because it cannot fit there. So yeah, it's actually like this. Yeah, that's fine. Okay, let's run this again. We should have, this might improve things. Still 6, okay. So I'm missing something here, pretty sure. What I wanted to do is to see how we're getting the other values. All we should be getting is 1s everywhere, basically. So for group count of 1, now arrangements, yes, because trying to fit the 3 there is not possible. So it should be 1. Okay, so far so good. Now we are getting a dot for group count of 1. So there the number of arrangements should be exactly 1 again. So yeah, for 2 and 1 is 1. Then we should have for 2 of 2 it should be 0. So 2, 2 should be 0. 2, 2 is 0, okay. Next, for 2, 3 should be also 0. And now we're at, so 2, 3 should be 0. And now we're at petal length of 3 and group count of 1. So petal length of 3 and group count of 1. So we're trying to put, okay, so we're trying to put the pattern there, and we're trying to find a number for pattern length of group count of y minus 1. So the number of arrangements for pattern length minus 1. So pattern length 1 and group count of 0. So that should be 3, 1 should be 0. Yes, it is. So far so good. So for 3 and group count of 2. So for 2 groups and 3 should be exactly 1. Three, 2 is 1, yes. Okay, so far as well, good. Now you have pattern length of, so this is dot. So we should be at 0, 4, 1 should be 0. Actually, let's run it until the very end, and let's see how the values look there, and where we are starting to get those high values. Oh, actually, I see. Okay, so the result was correct. Just I was running through the whole file, not just one line. So that explains it. So let's see if we run it on the file with question marks, and that's giving us 0 for some reason. That's kind of unexpected. Completely 0. So I get something wrong here. So initial 1. So 1 option, but then nothing else. That is very interesting. So let's see. So I want to see what's going wrong there, because this one is weird. So now we're at first character, which is a question mark. So it should be giving us pattern length, group count, one group. Okay, so it can be a dot. If the question mark is a dot, we should get to 0 there. 1 is 0. And if, all right, I made a huge mistake here. It should be not if, else if, but if. So now it should be better. 23 possible arrangements. 21 there. So still missing something here. So let's see. This one should give us 1 arrangement. Just to see where we're getting it wrong here. So 1 is fine. I'm guessing this could be a problematic one. 15. Yes, that's way too much. So it means that something else was wrong as well. So like this one is 2 and it should be 4 arrangements. So we are already wrong there. So let's see what happens here. So 2. So 11, 2 should be 3. So 11, 2 should be 3 arrangements. That's like already when we are here. So at 3 and 2, 3 and 1, we should have 2. 3 and 1 should be 2 and it's 1. So there is something wrong there. So let's see. 3 and 1. Let's see. Some edge case I didn't think about. So 3 and 1. So I will wait for 3 and 1 group. Okay. So at 3 and 1, we are at a character of question mark. So for if it was a dot, then we should have 1 arrangement there. 1 arrangement. And another one should be if it's a hashtag, because in that case, we should be arranging so pattern length is not equal to, and in arrangements for 3, 1 plus equals 3 minus 1 minus 1. So for length of 1, which is correct. So number of arrangements for a dot itself and 0 groups. And that should be 1. And apparently arrangements for 1 and 0 groups is 0, which is incorrect. So we need to initialize this properly, because this is not enough for oh, no. Don't do this. Okay. So for pattern length of what if I start with 0 groups there? Is it a problem for me? Will I be getting myself somewhere problematic? If I start here with 0, could it be? So yeah, group size of there is a if group count is equal to 0, then there is no way to arrange. So we must set it to 0. We must continue, or like, because we could have a question mark there. Does this make more sense? Well, it seems better. Maybe it was the problem. So let's see if this will help. If I put in this bigger input and run it. We get 21, which is way too much. Okay, we are still missing something. So I guess that's the initialization of group of pattern length 0. Because in pattern length 0, there is one way to initialize. Yeah, this should be fine. This should be enough, because only zero length can initialize zero length, zero number of groups. But afterwards, we should be fine here. So what else can be wrong? Okay, well, we fixed the first. The second one, we can check the third one now. So this one is giving us 2, and we should have just 1. So let's see. Let's see. Let's see. So the arrangements. So 3 and 1 should be 2, apparently. So 3 and 1 group should be 2 arrangements. And that is definitely not the case. There's just one way to do this. So I need to fix 3 and 1 and it should be fine. So 3 and 1. Okay. This is a complex debugging session. Long time no use of dynamic programming, so you can see that it is not easy for me to get back into it. So right now I have a character of question mark. So if it is a dot, then so 3, 1 should be now 0. Because there is no way to arrange group count of 0 on a pattern length 2, because there is already a definite hashtag. The problem is, can we I see what the problem is. Because what I'm doing is I'm checking if the pattern can fit there, but not checking if there is a dot as well before it, because that's the continuous group. There must be the continuous group and a dot before it. So if so dot distance equals. So what I will do is I will do something like this, where, or maybe I'll take while loop. So yeah, something like this. Or it can be a question mark, actually. It can be, it just cannot be. All right, yeah. the original approach was correct, but I need to just make sure that right now, when I know that I can place that group, there is also a dot before the group non. So it must be that yeah, minus group size equals, yeah, that should be it. Yes, I think so. So this should prevent me from placing that group right next to another one. So this fixed this scenario. So now let's see if we can solve this one as well, which is 4, which seems okay. And now finally this one, which is 10. Okay, this is now promising. I think we can try let's try the whole file, like multiple lines instead. It should be 21, yes. So now let's get our fingers crossed and try the big input file, and we'll see. 7,361. And that's correct. All right. All right, that's a relief. That was tricky. I didn't expect it to be this tricky, as I already thought about the solution, but I didn't think about all those edge cases that need to be handled. So good that it's working now, and let's switch to second part of the problem. So now we need to unfold the records. So we replace the list of spring conditions with 5 copies of itself, separated by a question mark, and replace the list of continuous groups of damaged springs by 5 copies of itself, separated by comma. So this becomes 5 copies of this, and okay, so this means that we are basically just increasing the original size of the input 5-fold. Around 5-fold. So I will test this on the small example first. So what I will do, so I will copy this to the part 2 file. So what I will do is that I will take the input and do pattern equals string join. Join it by question marks, and do what I want to do is enumerable repeat pattern 5. That should do it. And then the same thing with the groups. So I will do groups equals group concat enumerable repeat groups. No, so that should be it. So repeat, I will just repeat that group 5 times. What is it? What is it complaining about? Yeah, because this will... Right. So what I will do, just concatenate it 5 times. So for int groups less than 5, I will just do total groups new list, and I will just add it up there. Add range groups and I will just edit 5 times there. So simplified solution, and that should be it. So let's see what it can do against a big file now. Right. Let's just wait. What? Oh, right. That's the wrong input. I need this one. This one. Is it? Yes. Yes. So this one. 525. Okay, 525. Yeah, that seems good. So big input. And let's hope this works. Right. It's not a right answer. Okay. That's sad. That's pretty sad. Let's see. Can it be that it's overflowing? No, I guess not. So okay. Did I copy it correctly? Yeah, I did. So, So there is still some bug that I did not find. So now, but like this logic seems okay, but I hope it's not overflowing. That would be a surprise, though. Yeah, this is still the same. So the problem is somewhere else. What it could be it? What could be the? Five copies of itself. That's okay. So we have this right. The pattern should be also right. Let's just see if this looks correct, right? So So what did I miss? This is going to be quite harder to figure it out because now I don't have a way to compare this to anything. Because the sample input is working, so this will make it much harder to see what's going wrong. This input is working, right? So I just try again. So it's 525, 152. 525, 152. So this is fine. So there is some specific condition, some specific edge case that I did not manage to capture here. Oh, can it be that we're... Oh, that could be actually it, theoretically. That the individual ones are overflowing. Oh, it is probably it. I made this mistake. Okay, so that's a relief. I was going crazy for a while. But yeah, so the problem was that the arrangements for individual patterns then were overflowing int. So it caused us to get incorrect results here already. and that meant that the result was not correct overall. So that was quite a tricky one, but I'm happy that in the end it worked out. So yeah, we have both gold stars, so that's a good result. So I thank you for joining for a surprisingly long one, but I'm happy we pushed through it. So now we have both stars for day 12, and there will be more chances for the subsequent days. I will do another video for ChatGPT versus day 12 of Advanced Code, so stay tuned for that. And until then, keep coding, and I will see you in the next one. Bye bye.